Hello folks, we are coming to the part 5 video of this exercise 16.3. Yesterday we reached till the part 4, now it's a part 5. We are getting into the core of this exercise. All this time we were doing a lot of writing work. Now it is like the actual thing that will be requiring even for the next year and things like that. So let's go right away with the problem number 11. It says that there is a lottery which is numbered from 1 to 20. I'll read it. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. If these 6 numbers match with the 6 numbers already fixed by the lottery committee, then he wins the prize. What is the probability of winning the prize in the game? So there are numbers between 1 to 20. You are allowed to choose any 6 numbers. Once you choose these 6 numbers and you keep it, that is a winning lottery. That is the number that that is going to get the one second. A person chooses 6 different natural numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, so then that person wins the prize. So the lottery committee has already fixed the 6 numbers and they have kept in their mind 5, 10, 12, 1, like that. They have kept those 6 numbers ready with them in the lottery committee. Now the person who's winning the prize, if he in case gets that same number, then only he will win the prize. That's how he wins the prize. So this is how it is. So you have to find out the probability that a person is going to win the prize. Okay, so first of all we have to find out the sample space. So what is the sample space? We have to choose, even the lottery committee, what it has done, out of the 20 numbers it has chosen 6 numbers. Choosing, right, our good old days we have learned that choosing something is a combination problem. So we'll use the combination ideas and we will find out what is the sample space. Once we've got the sample space, then from there we'll find out the probability of that person wins the lottery. So that's how we're going to go about it. Let's see how we get across. We'll say that let S be the sample space. Let S be the sample space. And in order to know the number of elements in the sample space, we are choosing 6 numbers from the 20 numbers. So it's 20 C6. I don't know if we could have kept it like that, but we'll try elaborating it and let's see if we get a number. It is 20 factorial by 6 factorial by 14 factorial. That's how we learned. NCR is n factorial by r factorial into n minus r factorial. Or this is like writing 14 factorial into 15 into 16 into 17 into 18 into 19 into 20. And here we have the 14 factorial into 1 into 2 into 3 into 4 into 5 into 6. So you have the 14 cut, 6 3s are, 5 4s are, 4 and 4 can cut, then 3 5s are, and 2 8s are. So let's have the other things multiplied and see how it comes. We'll have 8 into 5 40. Let's have it like this: 8 into 5 40, 40 into 3 120. So it's like multiplying 120 into 17 into 19. Let's have 17 and 12 multiplied. 12 7s are 84, 8 carry. 12 1s are 12, 20. So 2040 totally. And this to be multiplied by 19. So 9 4s are 36, 9 2s are 18, and then 204. 3876, and that 0 continues everywhere. So it's 38760. That's the total number of elements in the sample space. Now once we have got this, we have to find out the probability that a person wins the ticket. Now when does that person win a ticket? A person wins a ticket if his number matches with the number that the lottery committee has fixed. Now how many choices do we have for that? We don't have many choices. We have got only one choice, because that number, whatever the lottery committee has chosen, the person concerned also should get exactly that number. You don't have choices at all. If he gets exactly that number, that's how he wins the prize. So we don't have much choices. It can be done only in one way, and because it can be done only in one way, therefore that's how the probability is going to work out. So we will say that let A be the event that a person wins the prize. Wins a prize. So how does it come? n of A is just that 1. So what is probability of A? It is n of A by n of S. That way it will come to 183,760. So that in so many ways that person will win the prize. That's about it, and that's it. Now what we are going to do is, from the next problem onwards, we are going to take one formula, and on the basis of that formula we are going to proceed and do the problems. We have an extension of that, or a part of it we have already done in the set chapter. We had learned that n of A n of A union B is n of A plus n of B minus n of A intersection B. So that extension of it we are doing here in terms of P. We will have probability of A union B is probability of A plus probability of B minus probability of A intersection B. So throughout now in the exercise we are going to use this formula and problems based on that, and that's how we are going to check. Now in this question they say if the given values are consistent, means whether such a value can exist. That is a question. So there are certain things that we have to keep in mind whenever we talk of consistency. You look at the set A and B, or event A and B, and you look at the event A intersection B. It's very clear to us that A intersection B is definitely going to be a smaller collection as compared to these both, either smaller or at least equal. So when we talk of the probability also, the probability of A intersection B should be less than or equal to probability of A and probability of B. So that is one thing that we check for consistency. Whenever we check consistency, we will check that. Similarly, it's clear to us that between A, B and A union B is a bigger set. So when we check the probability of A and B should be less than or equal to probability of A union B. So that much points you have to keep in mind whenever you have to check consistency. This is less than or equal to these both probabilities, but at the same time probability of A and probability of B is less than or equal to the union probability. So this is the condition that we are going to take in mind or keep in mind when we are going to check the consistency. So let's look at this first subpart. What does it say? You have probability of A as 0.5, you have probability of B as 0.7, and you have the A intersection, smaller one, the probability is 0.6. That's not possible, because you are having probability of A to be lesser than probability of A intersection B. That should never be the case, because A intersection B's probability should be less than or equal to probability of the individual set. So that we have to observe here. Probability of A intersection B is greater than probability of A. Therefore, what have they asked? Whether the probabilities are therefore probabilities are not consistently defined. Are not consistently defined. This is how we check whether it is consistently defined or not. Now next they are giving us a union, and in the union you have to check that the individual probabilities are less than the union. So we'll check probability of A is 0.5, probability of B is 0.4, and probability of A union B, which is a bigger set, is 0.8. No problem, they are consistently defined. So we can write here probability of A is strictly less than probability of A union B, and probability of B is strictly less than probability of A union B. Like that, the probabilities are consistently defined. Are consistently defined. Are defined, right? So that's about our problem number 12. Now problem number 13 is on the same lines, but fill in the blanks. We have to check, we have to do the blank filling. So here they give us probability of A, they give us probability of B, and they give us probability of A intersection B. What is probability of A union B? It's simple, straightforward, just the substitution. So let's check. It will be 1 by 3 plus 1 by 5 minus 1 by 15. This is going to be the probability of A union B. It's probability of A plus probability of B minus probability of A intersection B. Now equalizing into 5 into 3 into 5 into 3. So 5 plus 3 minus 1 whole by 15. That is 8 minus 1 by 15. It is going to be 7 by 15. Yeah. your value will come to 7 by 15. Same way, let's take the next one. In the next one, they don't give us probability of B, but they give us the other things. So we'll keep this in mind. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. What is given to us? Union is given as 6, 0.35. Probability of B is not given, and this is given as 0.25. Let's have everything coming on the other side. Why? Because we want to find the probability of B. So 6 minus 0.35 plus 0.25. So 6 minus 0.25 means it is 0.35 means 5.65 plus 0.25. So that is 10, 9, 35256. Now I should check once again if everything is okay. 6 minus 0.35 plus 0.25, 5 left. Let me go over it once again. 0.35, 0.25 and 6, correct. So this is 6, this is 0.35, this we don't know, and this is 0.25. We've taken everything on the other side, minus 0.35 and plus 0.25. Okay, once again let's do the subtraction. Minus 0.35, 5, 10, 9, 10, 5, 9 and 3, 6 and 5. Wait a sec, let's get it across. I don't know, some small, oh, this is not 6, it is 0.6. This is 0.6, that's the error, 0.6. Now let's proceed. Yeah, for this value this is the right answer, but then wrong question. So let's check. 0.6 minus 0.35, borrow 5, 10, 5, 2, 0.25, then plus 0.25, 5 and 5, 10, 5, 0.5. So this is coming to 0.5. Only looking at the answer won't do, na. You have to be careful about the question that you have written. For the given question, that answer was okay. So let's check now what happens here. Next one, third subpart. 0.5 is probability of A, probability of B is 0.35, and union is 0.7. This we don't know. So let's take this here. So it becomes probability of A intersection B, 0.5, 0.35 is already there, minus 0.7 will come here. So minus 0.5, so 0.5 plus 0.35, let's add. So it's 0.85. To that you are subtracting 0.7. So you're getting minus 0.15, yes, 0.15. So 0.15, that's right. So that's about it. that's about how we go across doing that problem. We are now with the 14th problem, and what is told in the 14th problem, that probability of A is 3 by 5, probability of B is 1 by 5. A and B are mutually exclusive. When they are exclusive, the intersection is 0, so probability is intersection is empty, and therefore the probability is also 0. So here what do we have? We have probability of A as 3 by 5, you have the probability of B as 1 by 5, and probability of A intersection B as 0. So by formula, probability of A union B is probability A or B is also A union B. So we can write that A or B is A union B, which is probability of A plus probability of B minus probability of A intersection B. So it's 3 by 5 plus 1 by 5 minus 0, which is 4 by 5. So probability of A or B is 4 by 5. That's the answer. The remaining problems we are taking it up in the next video. Thank you.